At our first edition of Image Ready, we had Jon Sneyers of Cloudinary join us to talk about the new kid on the block, the JPEG XL. Now, at the start of 2021, the bitstream would be frozen, signaling to tool authors and browser makers that the format was ready for adoption. A lot has happened since then, in fact, and we asked Jon Sneyers once again to see if he'd join us to talk about some of the updates. Well, he obliged. So here to talk about what's new with the JPEG XL is Jon Sneyers. Enjoy.
I'll try to give an update on JPEG XL, what happened in the past year since the Image Ready 1.0 event. So just to give a brief summary, so JPEG XL is a JPEG project. JPEG is, of course, well known for the first codec that they made, which is also called JPEG, confusingly. And it's still the most used image format. In fact, it's also the fastest growing image codec if you take into account progressive JPEG. And consider it as a separate format from the sequential JPEG, then progressive JPEG is actually the fastest growing image codec at the moment. And so it's a really great codec. It was there at the right time, just when the web was getting started, when digital photography was getting started. And basically for the past 30 years almost, it has been the codec for, at least for photographic images. So somebody has called JPEG the alien technology from the future, and it's quite unusual to have a codec that lasts that long. So the goal we have with JPEG XL is somewhat ambitious. We want to be the next generation of alien technology from the future. So we want to make an update of JPEG so that it can last another 30 years. So let's quickly go over the features of JPEG XL. So first of all, it's based on the old JPEG. So it still has DCT. It still has features that you have in the old JPEG, like progressive decoding. You can choose between 444 or 420, so chroma subsampling or not. And actually, in the new parts of JPEG XL, we don't do chroma subsampling anymore, but it's still supported. So existing JPEGs can be converted to JPEG XL in a lossless way. You don't have to decode the JPEG to pixels and then re-encode them with some new codec. They can be directly translated to JPEG XL, except they will be 20% smaller because of better entropy coding. But the image data will be exactly the same. In fact, you can restore the exact same JPEG file bit for bit from such a recompressed JPEG. So it's based on JPEG, but we have added quite a lot of things. So first of all, the DCT is no longer fixed to 8x8 blocks, but we have a variable sized DCT, so you can have a mix of blocks. We have improved the progressive capabilities of JPEG. We have worked on color spaces that are perceptually more relevant. We have adaptive quantization, so you can avoid artifacts in one place without having to bump up the quality everywhere. We have lots of extra stuff like splines and noise and patches that I cannot go into. And most of all, we also do lossless. We can do high precision, up to 32-bit per channel. And we support also an arbitrary number of channels. So you can have alpha, which was very much missing from the old JPEG, but also things like a depth map or thermal information or whatever else the future will bring. You can have multiple frames, you can have animations, you can have multiple layers of a still image. And it's also efficient to decode in parallel or just decoding a crop of the image, which is also something that is not really possible in JPEG. So we've added a lot of stuff, and if you look at the block diagram of the old JPEG, it's relatively simple compared to what we ended up with in JPEG XL, where we have basically two different modes, VAR DCT mode and a modular mode that are interwoven in many ways, and that have quite a bit more features than the old JPEG. So in terms of compression, I think it's fair to say that at the moment for still images, JPEG XL does give the best quality per bit, at least if you're interested in reasonable qualities. So let's say above quality 40 in LibJPEG terms. Then at that point, the curve of JPEG XL will be better than any other codec that is available. So what you could do in 1.8 BPP in MOS JPEG, you can do in JPEG XL in 0.75 BPP, at least on depending on the image, of course. But so that's a reduction of about 60% that can be trimmed away. So in terms of bandwidth reduction and faster loading, that's quite a good improvement. I think lossy is, for the web, probably the most important, except for some types of images that you might still want to use the lossless codec for. Cases where you currently, for instance, use PNG, because some things like logos or text is better encoded in a lossless way than using the DCT. So JPEG XL can also do lossless, and it's actually the best lossless codec currently available. So if you, for instance, compare to PNG, the percentages here are how many extra bytes you have in PNG compared to JPEG XL. So on average, PNG, and this is the most optimized PNG that we could create with like 5 different optimization tools. The PNG will be 46% larger than the JPEG XL. Depending on what type of images, the difference will be a bit larger or a bit smaller, but in basically all types of images, photographic, non-photographic, small images, large images, JPEG XL is consistently beating any other codec, including lossless WebP, which was currently the best available lossless codec, with, of course, its limitation to 8-bit, but within that limitation, it was consistently outperforming PNG, and now JPEG XL is also consistently outperforming lossless WebP. So that's, in terms of compression, good news. The other aspect is complexity. You can have great compression, but if it takes a long time to encode or decode an image, then maybe it's not so great, because in many cases, what you really care about is how long it takes to load an image or to save an image, including the transfer time. So you want to have good compression to reduce the transfer time, but if the decode, for instance, in the web takes too long, then probably it's not a great idea, even if you can save some bandwidth. And the same with encode. If encode is very slow, it might be problematic to deploy it at scale. It might be annoying to use it as a codec to save to, because if you want to save your image in Photoshop and every time you press Command S, it will take like 5 minutes, and your laptop starts to get hot from it. It's probably not very convenient. So the computational complexity of JPEG XL is relatively low. It has been designed that way so that the encode speed is quite reasonable. The decode speed can be also reasonable. Of course, it's hard to beat the old JPEG in this respect, because the old JPEG was designed for the hardware of the 80s. We do have a somewhat more complicated encoder and decoder than that, but still. One thing I did in the past year was write this blog post, which tries to compare the different codecs. And this was an infographic that tries to summarize at least my opinion about the different codecs, where you can see JPEG from 92, PNG, which is not really a lossy codec. So it's not really, well, lossy compression is not something it can really do. JPEG 2000 from 2000. WebP, which is also 10 years old now, I think, or 11, depending on how you count, I guess. And then you have the HEVC-based HEIC format that Apple is pushing a bit from 6 years ago. AVIF, which is currently getting adoption from 2019, and then JPEG XL from 2021. I'm saying 2021 because that's the year in which it was finalized. Of course, last year was 2020, and I was also talking about JPEG XL, but it wasn't finalized at that point yet. So yeah, you can search for the blog post to read more about it. So JPEG XL, it was created by a team in Google, and basically me from Cloudinary. And it took about 2 years to combine. We both had a proposal for what JPEG XL would be. There were 5 other proposals that were submitted to the call for proposals. And in the beginning of 2019, we started collaborating to turn our 2 proposals into a single codec. So JPEG XL became something that is better than just the sum of those 2, because we had 2 years of collaboration to make further improvements. So we started the project officially in April 2019 within ISO, or within the JPEG committee. We had the first draft in July 2019, which is still quite far from what the actual standard became. Then in January 2020, we had a somewhat more mature draft, the DIS, Draft International Standard. It got approved with a lot of comments that led to further improvements. And last year, I think, was around the time when we had addressed all of those comments and made the final version of the spec. I think back then I was hoping that we could still have the final version in 2020, but that didn't actually happen. At the JPEG meeting after the previous image ready, we decided to run some final validation experiments in the months of November and December. And then finally, end of December, we decided to freeze the bitstream. And in January 21, we officially submitted the final draft international standard that basically finalized the code stream format, which is the core part of the bitstream, the one that defines how the pixel data is encoded and all that. And then a few months later, we finalized part 2 of the specification, which is the file format, and which describes things like how the code stream is embedded into a file, how you can add XMP or EXIF metadata to it, and things like this. So part 2 is of course a lot shorter than part 1. So that happened. we currently have part 2. The FDIS was, I think, a week ago or so, it was officially approved. The part 1 FDIS still is on its way. So the process in ISO takes quite a while. And especially the ISO editors, they need quite some time to prepare the final documents for the ballot. But anyway, it will hopefully happen before the end of the year that we have the published international standard. In any case, the technical specification isn't going to change anymore. It has been frozen since January. So the next steps for the project are to continue the integration and adoption process, and also to work on part 3 of the specification, which will define the conformance criteria in case you want to make a decoder for JPEG XL and you want to claim that it conforms to the spec. Then part 3 will give you the criteria that it has to satisfy in terms of precision, in terms of like what it needs to do. Also in the past year, we have worked a lot on LibJExcel, which is the reference implementation of JPEG XL. We have changed its license to the BSD license. It used to be Apache 2. BSD is slightly more permissive. We opened up the development to external contributions. So before the bitstream was frozen, it was kind of an internal development process within the JPEG committee. But after the finalization, we opened it up, and it's now a public GitHub repository where everybody can make pull requests, open issues, join the discussion, and so on. Also, the project of LibJExcel is quite interesting because it evolved over time. So it started a few years back as a research prototype, and it became a validation model to test out new coding tools that we might want to add to the specification. It became the reference software, but usually reference software is a very slow, very, well, not production ready software. But in this case, in LibJExcel, we tried to do our best to make the reference software as robust and production ready as possible. And we're still in the process of improving it in that regard. So it's heavily getting fuzz tested and so on, so that we are sure that it's safe to include it, for instance, in a browser. So we have had a few releases since the image ready. So the first public release that had a version number was the 0.1 release in November. Then the 0.2 was basically when we said, okay, now the bitstream is going to be frozen. The 0.3 release in January had the first more or less stable API, so applications could start to use the LibJExcel decoder to decode JXL images. Then version 0.4 was the first one where we had the full features of the bitstream all implemented in the decoder. We didn't make an actual release out of it, but internally we had this version number 0.4. And so that means that basically a decoder from that version can decode any bitstream that a future encoder will produce. In version 0.5, we made quite a lot of encoder improvements to further improve the density and the quality of both the lossless and the lossy compression, mostly the lossy. And we're currently almost ready to release the 0.6 version. We've had some preliminary adoption. So we have experimental support for JPEG XL in Chrome and in Firefox. it's both behind the flag, so you have to manually enable the flag to get JPEG XL support. There's, well, not a lot of stuff happening in Safari as far as I can tell, but that's not so new. And then we have image libraries like ImageMagick, LibFips that are working on or already have integrated JPEG XL support. There's toolkits, especially in the Linux world. There's a lot that already works. There's quite a lot of Linux distributions where you can easily, or where it already works out of the box even, to show JPEG XL images. There are plugins for Windows and Mac to make it work there. There's one for the GIMP, and I think there's a lot of viewers that already support JPEG XL now. I think most of them actually. So we made good progress, I think, in terms of adoption. There's still a long way to go, especially to get JPEG XL support enabled by default in the browsers. Will take some more work, not really technical work, but mostly political work to convince the browser makers to do that. But yeah, I have a lot more slides with technical details, but I don't know how much time there is, and I first want to show something else, which is the JPEG XL homepage. So there's a community website. It's at jpegxl.info. Anyone can propose updates, by the way, to this website. It's hosted. There's a GitHub repository where you can just change it if you want to. And this image here is a JPEG XL image, and well, my browser has JPEG XL enabled. If I would view this page in Safari, but I'm not sharing my other screens, my other windows. Yeah, if I would open it in Safari, it would say your browser doesn't support JPEG XL. There's also an art gallery that contains some JPEG XL art, which is something also quite funny that happened in the last year, where we basically made it a kind of contest to make the smallest possible JPEG XL files that show something interesting. There's actually a tool to help you make those kind of JPEG XL files. Yeah, I don't have time to go into the details, but there's quite a lot of stuff that you can do in few bytes, like quite beautiful, I think, images in just a few dozen bytes. And this is taking advantage of the advanced entropy coding that lossless JPEG XL supports. So it's a rather fun activity to produce this type of art. Anyway, the other thing I wanted to show is so the community website I covered. So the Git repository of LibJExcel. So there's the reference implementation. It's now well, the code was already public last year, but the development process is public now, so everybody can make a pull request, open issues, and join a discussion in how we want to further like add functionality to the API and things like that. So I invite anyone to join that effort. All right. Henri, how much time do I have to give some more technical details?
Actually, thank you for asking, because we are probably going to move forward at this point. They're meant to be relatively short updates. So
Yes, exactly.
but what we could do is potentially set something else up that might be a more of a technical deep dive, so that we can sort of get into the entrails of everything that's going on. But I mean, this is certainly what I was hoping to hear. Some of the updates from last year and everything that was taking place. So that being said, I want to thank you very much for your time and providing some of that information. And you kept the best slide for last, because I was like, okay, what's going on the browser level? Because I knew there was some interest and things were taking place in the background. And I do like the mention of it not being a technical challenge, possibly a political one at this point, but we can get into the details about that another time.
Yeah. So just something I want to point to. So the slides that I'm using now, and that I also the ones that I used last year, they are also available on the community website, jpexl.info. So if you go to presentations, you find a link to JPEG XL overview, which is basically it started from the slides I used last year at ImageReady, as it says here, the original version of this presentation. But I've added a lot of stuff to it. So it's I've been updating it over the months. So you can always check when it was last updated with new information, and a lot of the technical details about all the coding tools in JPEG XL. You can take a look at the slides, and well, you're also free to add comments to the slides if you have questions or something that could be clarified. But there's quite a lot of information in these slides. So I want to thank Henri for pushing me to present last year and make these slides, because it became something that is, I think, still quite useful right now.
Well, you're quite welcome. I was happy you could join us, because I knew it'd be the perfect opportunity for you to have sort of like that conversation. So, I mean, that being said, Jan, thank you very much.